Our universe is vast, stretching far beyond what we can see with the naked eye. It's filled with billions of galaxies, each one a massive collection of stars, planets, and cosmic dust. Each galaxy has billions of stars, many of which have their own planetary systems. Our own galaxy, the Milky Way, is just one among many, a single speck in the grand tapestry of the cosmos. Imagine a grain of sand, tiny and seemingly insignificant. Now imagine all the grains of sand on all the beaches on Earth, each one representing a star. That's how many stars we think are in the observable universe, a number so large it's almost beyond comprehension. It's a truly mind-boggling scale, where even the smallest objects are incredibly massive. But the universe is not just big, it's also incredibly complex, with intricate structures and phenomena. Stars explode and die, creating the elements that make up everything around us, from the air we breathe to the ground we walk on. Galaxies collide and merge, forming new stars and planets in a cosmic dance that has been ongoing for billions of years. Black holes, with their immense gravity, warp space and time, creating phenomena that challenge our understanding of physics. The universe is a place of constant change and evolution where nothing stays the same for long. It's a place of incredible beauty and mystery, filled with wonders that captivate our imagination. And it's a place that we are only just beginning to understand, with each discovery leading to new questions. As we explore the cosmos, we are filled with wonder and a sense of our own smallness in the grand scheme of things. The universe is a vast and mysterious place full of secrets waiting to be uncovered, inviting us to keep looking up and asking questions. We can only see a small part of the universe from Earth. This is because the universe is only 13.8 billion years old. Light takes time to travel. The farthest we can see is the distance light has traveled to us in that time. This visible part of the universe is called the observable universe. It's like a bubble centered on us. Everything beyond this bubble is currently invisible to us. This is because the light from those distant regions hasn't had enough time to reach us yet. The edge of the observable universe isn't the edge of the actual universe, it's just the limit of what we can see right now. Light travels incredibly fast, moving at a speed that is almost unimaginable to us. It races through space at approximately 299,792,458 meters per second, which is the fastest speed in the universe. This speed is incredibly fast, but the universe is incredibly vast, stretching out over billions of light years. Even at this astonishing speed, it takes time for light to travel across the cosmos, crossing immense distances. When we look at distant objects in space, we are seeing them as they were in the past, because the light has taken so long to reach us. The light from those objects has been traveling through space for millions or even billions of years to reach us, carrying with it the history of the universe. For example, when we observe a galaxy that is 1 billion light-years away, we are seeing it as it existed 1 billion years ago, a snapshot of the distant past. The light from that galaxy has been traveling through space for 1 billion years to reach our telescopes, a journey that began long before humans existed. This concept, known as lookback time, is crucial to our understanding of the universe, as it allows us to peer back into the history of the cosmos. It allows us to study the history of the cosmos and witness events that happened long ago, providing a window into the formation and evolution of galaxies, stars, and planets. The universe is not static, it's constantly expanding. This means that the space between galaxies is stretching and growing over time. As the universe expands, distant galaxies are moving away from us. The farther away a galaxy is, the faster it appears to be moving away from us. This observation is the foundation of Hubble's law, a cornerstone of modern cosmology. Interestingly, some galaxies are moving away from us faster than the speed of light. This doesn't violate the laws of physics, as it's the space between us and those galaxies that's expanding faster than light can travel. Imagine baking a loaf of raisin bread and placing it in the oven. As the bread bakes, it expands, causing the raisins to move farther apart. Similarly, the expansion of the universe causes galaxies to move away from each other. Section 5. Beyond the cosmic horizon, the multiverse. What lies beyond the observable universe? It's a question that has intrigued scientists and philosophers for centuries. While we can't directly observe this region, there are several theories about what might exist beyond our cosmic horizon. One intriguing possibility is the existence of a multiverse. The multiverse theory suggests that our universe is just one of many universes, each with its own unique properties and laws of physics. These universes might be vastly different from our own, with different dimensions, particles, and forces at play. The multiverse theory is still highly speculative, but it has gained traction in recent years due to advancements in theoretical physics and cosmology. If proven true, it would revolutionize our understanding of the universe and our place within it. Section 6. Multiverse Wonderland, where physics gets weird. Imagine a universe where gravity is weaker than a gentle breeze, or where time flows backward. These might sound like concepts from science fiction, but they are entirely plausible within the framework of the multiverse theory. Different universes could have different physical laws and constants. In some universes, gravity might be so weak that stars and planets could never form. In others, the electromagnetic force might be so strong that atoms would be ripped apart. The possibilities are truly endless. The multiverse theory allows for an incredible diversity of universes, each with its own unique set of physical laws and properties. Section 7. The shape of the universe, a cosmic mystery. The shape of the universe is another intriguing mystery that cosmologists are trying to unravel. This question has fascinated scientists for decades, leading to numerous theories and extensive research. There are three main possibilities: flat, closed, or open. Each of these shapes has unique characteristics and implications for the fate of the universe. A flat universe would extend infinitely in all directions like a sheet of paper. This means it would have no boundaries and would continue forever. A closed universe would be finite and curved like the surface of a sphere. In this scenario, if you traveled far enough in one direction, you would eventually return to your starting point. An open universe would be infinite and curved like the surface of a saddle. This shape implies that the universe would expand forever, never looping back on itself. The shape of the universe is determined by its density. This critical factor influences whether the universe is flat, closed, or open. If the density is above a certain critical value, the universe is closed. This means it has enough mass to eventually stop expanding and start contracting. If it's below the critical value, the universe is open. In this case, it will continue to expand indefinitely, growing ever larger and more sparse. And if it's exactly at the critical value, the universe is flat. This delicate balance means it will expand forever, but at a rate that slows down over time. Current observations suggest that the universe is very close to being flat, but more precise measurements are needed to confirm this. Scientists continue to study cosmic microwave background radiation and other data to refine their understanding. Section 8. The Big Rip Cosmic Disintegration. The fate of the universe is a topic of much speculation. One possible scenario is the Big Rip, a catastrophic event where the universe's expansion accelerates uncontrollably. In this scenario, the expansion would eventually become so rapid that it would overcome the fundamental forces holding matter together. Galaxies, stars, planets, and even atoms would be torn apart. The Big Rip is a rather bleak end to the universe, but it's just one of several possibilities. Section 9. The Big Freeze, a universe in permafrost. Another possible fate for the universe is the Big Freeze, also known as the heat death. In this scenario, the universe continues to expand and cool down over time. As the universe expands, matter and energy become more spread out, leading to a decrease in temperature. Eventually, the universe would reach a state of maximum entropy, where all energy is evenly distributed and no more work can be done. The Big Freeze is a more gradual end than the Big Rip, but it's no less final. In this scenario, the universe would eventually become a cold, dark, and lifeless place. Section 10. The Big Crunch, a universe in reverse. In contrast to the Big Rip and the Big Freeze, the Big Crunch proposes a scenario where the universe's expansion eventually reverses. In this scenario, gravity would eventually overcome the expansion, causing the universe to contract. As the universe contracts, galaxies would draw closer together and the temperature would increase. Eventually, the universe would collapse in on itself in a fiery inferno, mirroring the Big Bang in reverse. The Big Crunch is a dramatic and somewhat poetic end to the universe, but it's less favored by current cosmological models compared to the Big Freeze. Section 11. Journey into the Unknown. The universe is a vast and mysterious place full of wonders that we are only beginning to comprehend. The possibility of what lies beyond our observable universe, the nature of the multiverse, and the ultimate fate of the cosmos are all questions that continue to captivate our imagination. Imagine embarking on a journey beyond our cosmic horizon, venturing into the uncharted territories of the multiverse. What wonders might we encounter? What strange and exotic forms of matter and energy might we discover? While such a journey remains firmly in the realm of science fiction for now, the quest to understand the universe and our place within it is a journey that we are all on.